So for lesson 10.3, we are actually solving rational equations. So these are going to be different than all the problems we've had before because our problems are going to be presented like this: x divided by x minus 3 equals 2. And the reason that they are different and what they have that nothing else has had before is they have this equal sign here. So the way that we're going to work these out is going to be a little bit different, and the answer that we're looking for is also a little bit different. But that does not change the things that we need to do about the problem. So we still need to, as always, identify any excluded values in my problem. So my excluded values or my restricted values, I get those whenever my denominator is equal to 0. So whenever my denominator is equal to 0. So I have my denominator in this case is x minus 3. And if I were to set x minus 3 equal to 0, and solve, then to get rid of this minus 3, I would need to add 3 to both sides. And 0 plus 3 is going to give me 3. So there is an excluded value at 3. And then I would need to actually solve this problem. Well, there's a couple ways I can do this. I can do this graphically. The first thing I'm going to graph is x divided by x minus 3. And then I'm also going to graph 2. So I've graphed my two functions, and I use Desmos to graph them because that's the easiest thing for me to do when I'm working with the iPad. My first function was x minus 3, and that is my function that is actually blue. So I'm going to make sure y'all can see that it is my blue function here. And then my second thing I had to graph was y equals 2, which is my green function. So what I'm looking for is where they intersect. It doesn't look like they intersect out here to the left side, and they really aren't, because if you think about your triplets, Bobo, Botan, and Betsy, this actually is going to have a horizontal asymptote at 1, so it's going to keep getting closer and closer to 1 as I go out to the left, but it's never going to actually be 1. But on the right side, this blue line, or my blue curve, is going to intersect my green line, my y equals 2, and they intersect at the ordered pair 6, 2. So that means my solution to this problem would be x equals 6. So I found my solution from the graph. Again, we said that they intersected at 6, so we think that's our answer. But if I'm just following the steps here, we've gone through A, B, C, and D. We're looking at step E, where it says identify any x-intercepts of the graph. Remember, x-intercepts occur whenever my numerator is equal to 0. So whenever my numerator equals 0. Well, my numerator in this case was x, so I need to set it equal to 0. Well, obviously that means there's an x-intercept at 0. And if we look at our graph here, that makes sense because my blue graph obviously crosses the x-axis at 0. So the last question is, we need to make sure that our x value, our solution of 6, is not an excluded value. The excluded values come from my asymptotes or my restricted values. Well, the only restricted value we had, or excluded value, was 3. So obviously that's not my answer, so my answer to my problem would be 6. Now, graphically is actually not, it's probably the easiest way to graph these, but it's also sometimes the most complicated to understand. So we're actually going to spend the next few minutes learning how to solve these rational expressions by hand. So I want you to skip over to page 545. We're going to look at problem 3, because really the best way to solve these by hand is to actually do them. So I have the problem x plus 6 divided by 8x minus 24, and we are actually going to turn this word and into an equal sign. So if you will replace that right there, that would be super helpful. So I'm going to take this word and out, and I'm going to replace it with an equal sign. And we are actually going to learn how to solve these. So in order for us to solve these, I still have to have common denominators. I still need common denominators. And you're probably thinking, well, there's an easier way to solve this problem. And yes, there is an easier way to solve this particular problem. I could use this as a proportion, but that's not going to help me later on. So just bear with me as we work through this. So in order to find common denominators, I must first factor each of my denominators. So I'm going to leave my x plus 6 alone on top. I have 8x minus 24. I can factor an 8 out of that, and I'm left with x minus 3. So I did not make that up. That 8x minus 24 factors into 8x 8 times x minus 3. So I'm going to do the same thing on the other side. I'm going to leave my numerator alone. So 14x divided by, I can factor a 10 out. So I'm left with x minus 3. And so again, I did not make that up. Rather, I factored 10x minus 30 into 10x minus 3. So I'm looking for my two denominators. I need them to be the same. So that means I have to figure out what is missing from my factorization on the left side that my right side has. Well, notice they both have an x minus 3. That's fantastic. But I have an 8 and a 10, so I need the lowest common multiple of 8 and 10. That will give me my least common denominator. Well, if I multiply 8 by 5, then I get 40. And if I multiply 10 by 4, I also get 40. So my lowest common denominator is going to come from these two pieces. Well, if I multiply the denominator by 5, I must also multiply the numerator by 5 on the left. And on the right, I must multiply my numerator by 4. So that really gives me the problem 5x plus 30 divided by 40 times x minus 3 equals, and 14x times 4 is going to give me 56x divided by 40 times x minus 3. I'd like for you to notice that our numerators here our denominators are identical. If my denominators are identical, then I can actually completely ignore them. If my denominators are the same, I can completely ignore them and focus on my numerators, which is 5x plus 30 equals 56x. Well, now I can solve this problem like I would solve anything else. So I'm going to minus 5x from both sides, and I get that 30 equals 51x. And if I need to get x by itself, then I would divide both sides by 51. And I get that x equals 30 divided by 51. So that looks like it's going to be my solution. The only thing I need to check now is I need to make sure that I know what my excluded values are. So to find my excluded values, I focus on my denominator. So my excluded values happen whenever my denominator equals 0. So the only factor that I really had in my denominator was x minus 3. So I need to find out what makes x minus 3 equal to 0. And the answer to that question is when x equals 3. So notice that my answer that I came up with was 30 over 51. And the answer that x cannot equal is 3. Since they're not the same number, then I have my solution. So now we're going to solve problem 4. So the very first thing I need to do is I need to factor both of my denominators. So I have 12x still on top. I'm going to leave my numerators alone, divided by 15x plus 60. If I factor that, I can factor 15 out, and I'm left with x plus 4. So that 15x plus 60 factors into 15 times x plus 4. And then that equals, on top I still have 5, and I need to factor x squared plus 9x plus 20. So if I'm going to factor that, I need to think about what numbers can I multiply together that will give me 20, that I can also add together, and will give me 5, and that becomes x plus 5 and x plus 4. So when I factored x squared plus 9x plus 20, I got x plus 5 and x plus 4. So now I need a common denominator. I need my denominators to be equal. So if we look at the left side, the green side, it is missing an x plus 5 that the right side has. So that means I need to multiply the left by x plus 5. If I multiply the bottom by x plus 5, I must multiply the top by x plus 5. And the right side is missing a 15. And so I need to multiply the numerator by 15 as well. So on top, I'm going to need to distribute. So x times 12x would be 12x squared. And 5 times 12x would be 60x. And then on bottom, I'm going to leave my factors all there. I'm not going to mess with them yet. So x plus 5 times 15 times x plus 4. And that equals 5 times 15 on top is going to give me 75 over x plus 5 times x plus 4 times 15. So remember that my denominators, I need those to figure out what my excluded values are. So I'm going to go ahead and do that now because why not? So my excluded values come from my factors of my denominator. So that's what x cannot equal. Well, if my first factor is x plus 5, that means x cannot equal negative 5. If my second factor was 4, then that means x cannot equal negative 4. So those are my two excluded values. So just like with the previous problem, I want you to notice that my denominators are identical. And whenever my denominators are identical in a proportion, I can actually ignore them completely. If I'm solving this, I can ignore my denominators, and I'm really left with the problem 12x squared plus 60x equals 75. And this is what I need to solve. Well, there's a couple ways we can solve, but before we can do any of those, we need to get this 75 to the left side because this is a quadratic, so I can't just do some simple math. In order to solve, I'm going to have to do one of two things. I'm either going to have to, option 1, don't necessarily write this down, but option 1 is I'm going to have to factor, and option 2 is I'm going to use the quadratic formula. So, since these are rather large numbers, 12, 60, and 75, factoring is really not going to be a good choice for us. So the quadratic formula would be our best option. But I've actually already done this problem, and these numbers are quite terrible. So we're going to just set this up in the quadratic formula, and then we're not actually going to work it out. So my quadratic formula, if you'll recall, I'm going to write this formula over here for us so we have it, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to plug in what I already know. Well, negative b would be negative 60 plus or minus the square root of b squared, so 60 squared, minus 4 times a, which is 12, times c, which is negative 75, all over 2 times 12. As I said a second ago, this is going to give you some pretty nasty numbers. So if you would like to put it in the calculator and get an answer, you're more than welcome to, but we're going to leave it as is for now. So these would actually represent my two solutions. So this problem would have two answers. So if you'll skip over to page 546, we're going to work on this problem, problem 5. So I have 8 over x plus 3 equals x plus 1 over x plus 6. I don't have to do any factoring, which is really nice. So I've just got to figure out what my denominators are missing so I can get a common denominator. Because once I have a common denominator, my life is quite wonderful. So I have 8 over x plus 3 equals x plus 1. I'm going to go ahead and put that in parentheses over x plus 6, which I'm also putting in parentheses. So if I need my denominators to be the same, then on the left, the denominator is missing an x plus 6. That would make them, so that would be the factor that needs to be on the left. So I multiplied by that on bottom, I have to multiply that on top. And then on the right, in order to keep my denominators the same, I have to multiply by x plus 3. If I do that on bottom, I have to do that on top as well. So I can go ahead and multiply out the top part. So x plus 6 times 8 is going to be 8x plus 48. Over, I'm going to leave this as x plus 6 times x plus 3. And that equals, over on the right side, I have to FOIL. X plus 1 times x plus 3 is x squared plus 4x plus 3 over x plus 6 times x plus 3. So notice that my two denominators are identical. So since my denominators are identical, I can actually ignore them, and I can just work on solving my numerators. And we'll get to the excluded values in a second. So my numerator says that 8x plus 48 is equal to x squared plus 4x plus 3. So I need to get everything onto one side, so I'm going to minus 8x from both sides. I'm also going to minus 48 from both sides. So I end up with 0 equals x squared minus 4x minus 45. So I need to see if I can factor this so that I can solve. Well, if I'm going to factor this, my coefficient, thankfully, of x squared is just 1. So I'm going to have x and x. I need two numbers that when I multiply them, they give me negative 45. That tells me one of them is positive and one of them is negative. And when I add those same two numbers, I get negative 4. So thinking through my factors of negative 45, I'm going to end up with a negative 9 and a positive 5, because negative 9 times 5 is negative 45, and negative 9 plus 5 is negative 4. And again, this equals 0. So if I know that this whole problem equals 0, then that means that x plus 5 equals 0, or x minus 9 equals 0. So I'm going to set solve each piece of this. So I'm going to minus 5 from both sides. And my first answer that I get for x is negative 5. That's my first solution. So right now I'm finding my solutions because I'm worried about the numerator equaling 0. And I'm sorry, my numerators being equal. And then for my second solution, I'm going to add 9 to both sides, and I get that x equals 9. So these are my two solutions that I have come up with so far, negative 5 and positive 9. The only thing I have left to do is I have to make sure that neither of these is considered a restricted value or an excluded value. We're going to do a problem in a second where it does have one of these. So if it's restricted or an excluded value, that is when the denominator is equal to 0. So my factors of my denominator were x plus 6 and x plus 3. So my two restricted values, x is not going to be equal to negative 6 and x cannot equal negative 3. And thankfully, neither of my answers was negative 6 or negative 3, so my solution stands as is. So now we're going to go back up and do problem B at the top of this page. So notice that this problem now has 3 pieces to it. It has 3 terms. So that doesn't necessarily change the way we approach the problem. We still first and foremost need to have common denominators. So I'm going to take my expression, I'm going to rewrite it. I'm just going to use this space over here to the right. So I have 2x minus 9 over x minus 7 plus x over 2 equals, and I'm going to leave some space because I know I'm going to have to do some math stuff and to make sure these denominators are the same, 5 over x minus 7. So in order for me to be able to actually do any math and to solve this, I need all 3 of these denominators to be exactly the same. Well, this one has an x minus 7. This one has a 2, which means that, first of all, this one is missing. This middle term is missing a denominator of x minus 7 that it needs. So if I multiply the bottom by x minus 7, I must multiply the top by x minus 7. So that's the first thing I need to add in. Well, now my middle denominator has a 2 and nothing else has a 2, so I need to multiply both my first term and my on the right side by 2 so that all of my denominators are now the same because all my denominators have 2 and x minus 7 in them. So if I distribute on top, I have 4x minus 18 over 2 times x minus 7 plus x squared minus 7x over 2 times x minus 7 equals 10 over 2 times x minus 7. So since all of my denominators are exactly the same, and anytime this is true, if all my denominators are exactly the same, then I can ignore all of them. And I just need to worry about the numerators. So we'll come back to the excluded values in just a second. So my numerators say that 4x minus 18 plus x squared minus 7x is equal to 10. So I need to manipulate things. I need to combine like terms. So one of the things I need to do is I need to minus 10 from both sides. So, and in that same step, I'm going to go ahead and rewrite this as x squared. I can combine my 4x and my minus 7x, which is negative 3x. And then my negative 18 and my negative 10 is negative 28. equals 0. So I need to factor this so that I can solve it. Well, I'm looking for two numbers that when I multiply them, they give me negative 28, which means that I'm going to have a positive and a negative. And those same two numbers, when I add them, gives me negative 3. So that's going to be a negative 7 and a positive 4. So now I can set each of those factors equal to 0. So to find my solutions, I'm going to set x plus 4 equal to 0 and solve, which means that my first solution is negative 4. And I'm going to set x minus 7 equal to 0, so my second solution is at positive 7. So far, these are the two solutions that we have come up with from doing math. So now we need to figure out what my excluded values are. So remember, my excluded values happen whenever my denominator is equal to 0. Well, if I look at my denominator, I had 2 as part of my denominator. Well, that can never equal 0. And I had x minus 7. So if I set x minus 7 equal to 0, that means that x cannot equal 7. So what I want you to notice is that when we solved our problem, one of the answers that we got for x was 7, but we just did some work that said x cannot be 7. So because x cannot be 7, that is an excluded value. That means that x equals 7 is what we call an extraneous solution. This is considered an extraneous solution. So my actual answer to this problem, I only actually have one, and my solution is simply x equals negative 4. So, and the reason is because because positive 7 was an extraneous solution. And the reason it was extraneous is because it showed up as an excluded value or as a restricted value, and it showed up as a solution. It cannot be both. So looking at page 547, we're going to solve some real-world problems where we have rational equations. So it says Kelsey is kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, she can travel at an average speed of 3 miles per hour. What is the average speed of the river's current? So just identifying some important information here. First of all, it says that the answer will be the average speed of the current. That's what I am looking for, is how fast is the current moving. She spent a total of 6 hours kayaking. And she traveled 5 miles upstream and 5 miles downstream. And her average speed in still water is 3 miles per hour. So when she's traveling, if C represents the speed of the current, then when she's going upstream, she's going against the current, which means that the current is slowing her down. So her speed is going to be equal to her speed in still water minus C. So going upstream, her average speed is 3 minus C. And then when she's going downstream, then she's going with the current, so the current's actually helping her out, and she's going faster, so her speed is going to be 3 plus C. Now, it is important to note that my variable C, my speed, is restricted to positive real numbers. So that means I cannot have a negative speed. I'm not focusing on that. My speed can only be positive, and it must be a real number. It cannot be an imaginary number. So if I know that my distance is 5 and my speed I have 3 minus C, well, to write my time, we can look back at our triangle, and our distance equals our speed times our time. So my time is equal to my distance divided by my speed. So for going upstream, my time is going to be 5 divided by 3 minus C, and going downstream, my time is 5 divided by 3 plus C. Since my total time was 6, that means that 6 is going to equal 5 divided by 3 minus C, so my upstream speed, plus my downstream speed. So 5 divided by 3 plus C. So this is my equation that I need to solve. So if I'm going to solve this, I need for these, I'm going to rewrite this first of all. So I have 6 equals 5 over 3 minus c plus, I'm going to actually leave a little bit of space here, so plus 5 over 3 plus c. So in order to solve these, I need to have common denominators. Well, my 6, by the way, has a denominator of 1, so it doesn't have anything, which is kind of nice. So in order for my denominators to be the same, let's start with this first one over here. Let's start with the last one on the right. So the denominator is 3 plus c. Well, in order for all of these other two to have the same denominator, I need to multiply by 3 plus c on both top and bottom. So I'm going to do that for both the 6 and then the 5 over 3 minus c. So, alright, so everything has a 3 plus c. Now, in order for my denominators to be the same, they also must all have a 3 minus c. So I need to multiply the first one by 3 minus c, and then I need to multiply the last one by 3 minus c over 3 minus c. So now all of my denominators are the same. So I can do some multiplying here. I have 3 minus c times 3 plus c. Well, that's actually going to be 9 minus c squared times 6 over 3 minus c times 3 plus c. And that equals, I can distribute 5 times 3 would be 15 plus 5 times c would be 5c over my denominator of 3 minus c times 3 plus c. And then I can again distribute 5, so that would be 15 minus 5c over 3 plus c times 3 minus c. So notice that all of my denominators are exactly the same. So if all of them are the same, then I can ignore all of them. And I will just treat this as a problem with numerators. We're going to come back to the denominators in a second for my restricted values. But for my solving, I can ignore them. So I'm going to go ahead and distribute this 6 as well. So I have really 54 minus 6c squared is going to equal 15 plus 5c plus 15 minus 5c. So on the right side over here, this plus 5c and minus 5c cancel. So I really have 54 minus 6c squared equals 30, because I can go ahead and combine those 15s together. So I need to solve this. Well, solving, remember, there's 3 ways to solve. So I can solve by factoring, I can solve by quadratic formula, or if I just have like x squared equals something, I can solve that as well. So what I'm actually going to do is I'm going to minus 54 from both sides, and that is going to give me negative 6c squared equals negative 24. So now I can, to get x by itself, or c by itself, I can divide both sides by negative 6, and I get c squared equals 4. And then lastly, if I take the square root of both sides, I get c equals positive 2 and negative 2. Because whenever I take the square root, I always have the positive and negative form. So the two solutions that we have come up with so far are positive 2 and negative 2. Well, there's a problem with one of those for sure. The first thing was, since C represents my current, we originally said that C was restricted to positive real numbers. Well, if I look at my answers that I came up with an answer of negative 2, so that's not going to work because it is not positive. So far, my only actual possible answer that we've come up with is positive 2. So now we need to check for our restricted values or our excluded values. So either word, restricted or excluded values, just to make sure that that doesn't conflict with what we have worked out our answer to be. So those come from when my denominator is equal to 0. So my denominator was 2 factors. And the first factor in my denominator was 3 minus c, and my second factor in my denominator was 3 plus c. So if I were to solve both of these, then I would get that c cannot equal positive 3, and I would also get that C cannot equal negative 3. So my solution that I have right now is positive 2. The things that I'm saying that it cannot be is it cannot be 3 or negative 3. Well, thankfully, these don't conflict, so C is 2 is my answer. So that tells me that my current for this particular stream is flowing at 2 miles per hour. So that is my final answer. So if you will move over to page 549, problem 7. So Kevin can clean a large aquarium tank in about 7 hours. When Kevin and Laura work together, they clean the tank in 4 hours. So write and solve a rational equation to determine how long to the nearest tenth of an hour it would take Laura to clean the tank if she worked by herself. So just starting, what we know is that if it takes Kevin 7 hours to clean the tank, that's the first thing it said, is it takes Kevin just 7 hours to clean the whole tank. So if it takes him 7 hours, that means that in 1 hour, so for Kevin, in 1 hour, he can clean 1/7 of the tank per hour. And that's logical, because if it takes him 7 hours to clean the whole thing, then in 1 hour he cleans 1/7 of it. Well, then I'm looking at Laura to see what we know about her. It doesn't tell us how long it takes her to clean the entire tank. So we could say that if it took her, we're going to say right now that it's going to take her T hours to clean the whole tank. So that means that in 1 over T, that she can clean 1 over T of the tank per hour. So she can clean a portion of the tank every hour. And we don't know what that is because we don't know exactly how long it takes her. So what we do know is that together, that Kevin plus Laura can clean the whole tank in 4 hours. So if this is our rate, 1/7 of the tank per hour, that's our rate that we're cleaning at, then Kevin's rate plus Laura's rate is going to have something to do with 1 full tank. But it's not just 1/7 plus 1 over T, it's 1/7 times 4. Because we know that it takes them 4 hours together to clean 1/7 of the tank. So on the left side over here for Kevin, this tells us how much of the tank Kevin's going to clean, while simultaneously Laura is also cleaning part of the tank. So here's my equation that I'm actually going to be able to work out. So if I multiply this out, I have 1 over 7, which is really going to be 4 over 7 plus 4 over T is going to equal 1. So I need these all to have a common denominator. So I'm going to go ahead and put this 1 on the right over 1. So to get a common denominator, then I need to make sure that everything has a T in the denominator. And if I multiply by T in the denominator, I must multiply by T in the numerator. The other thing that all my denominators should have is kind of looking at what I have there is I need a 7. So I'm going to multiply by some 7s to help me get my denominators the same. So now all of my denominators, if I rework my problem or rewrite my problem, I have 4T over 7T plus 28 over 7T equals 7T over 7T. And since all of my denominators are exactly the same, then I can ignore the denominators and I can just focus on my numerators, which says that 4T plus 28 equals 7T. So this is something that I need to solve. Well, that's easy to solve. So to get T by itself, I'm going to minus 4T from both sides. And I get that 28 equals 3T. So to get T completely alone, I would divide by 3. And I get that my time it's going to take Laura to clean the entire tank is 28 over 3 hours, which if you work that out, that would be 9 1/3 of an hour, Well, a third of an hour is 20 minutes. So it's going to take her 9 hours and 20 minutes to clean the tank. So that's the time that we have come up with. Now, the only thing we have to do is we have to make sure that that doesn't conflict with our restricted values. Those restricted values are going to get you every time, or the excluded values. So remember, my excluded values happen whenever my denominator equals 0. Well, all my denominators had a simple factor of 7t, so that cannot equal 0 for my excluded values, which means that t cannot equal 0, so Laura's rate cannot be 0. Well, lucky for us, Laura's rate that we calculated her to have was 9 hours and 20 minutes, which is not 0, so that means that her speed is actually, to clean the entire tank, is in fact 9 hours and 20 minutes. So for your homework, you are going to do problems 3 through 14 and 16 and 17. So that's your assignment. So if you will look really quickly at 3 through 8. So for 3 through 8, I want you to change the word "and" to an equal sign. So really this is going to be the problem x over 2x plus 16 equals negative 4x over 3x minus 27. And you are going to have to solve this problem. So for 3 through 8, make sure that you change the word "and" to an equal sign. So you're going to change the word "and" to equals. And then you are also going to solve. So remember, ways to solve, you might want to write this down. This would probably be helpful. So ways we can solve is if it's a linear factor, that's nice. So linear factors are when I have like 4x plus 3 equals 12. That's easy to solve. I can solve by factoring. I can solve by using the quadratic formula. And lastly, I can also solve if I have square roots. So if I have something like x squared, square roots. If I have something like x squared minus 16 equals 0, I can solve this by taking the square root of both sides after I move the 16 over.